Now let's look at question number 2. It's on waves and optics. We have a ray of light that is traveling from a dense medium A to a less dense medium B, which has a critical angle of 45 degrees. If the speed of light in medium B is 3 times 10 to the 8 meters per second, what is the speed of light in medium A? So let me quickly sketch those two media. So let's say this is medium A, and let this represent, let me use this now. Let this represent medium B. I'm going to put them together right here. So there's what we call refraction in physics. Refraction is simply the bending of light whenever light travel through different media of varying density. So this bending of light is actually brought about by so many things. One of them is the change in speed. In some media, light travels faster, and in other media, light travel slowly. By density, if you are of higher density, light is going to travel in such medium, and if a medium is of lesser density, light is going to travel faster in such medium. Now, for this particular situation, now let's say this is medium A, and let this be medium B. Of course, from the information here, medium A is a denser medium than medium B. That implies that light is going to be traveling faster in B than in A. So automatically that implies that if speed in B is 3 times 10 raised by 8 meters per second, that implies that we only have two possible answers. That will be either option A or option B, because it cannot be the same speed in A as well, and the speed cannot be greater in A as well, based on what I've explained. So how do we approach this kind of problem? So the concept of refraction, as light is traveling from this place, so normally it should have continued at this path. It should continue this path and begin to go like that. So let me draw that with a broken line. So you see the path that it ought to take on a normal day. So if it was traveling, it should have continued on this path. But because light has changed from a different medium to another medium, in this case, from a denser to a less dense medium. So the way it works is that when light travels from a denser to a less dense medium, light is going to bend away from the normal. Light is going to bend away from the normal. And what do I mean by that? This is what I mean by that. So light has two different ways to move now. If it's not going to continue in this path, it can either move towards this place or it moves towards this place. But because we are coming from a denser to a less dense medium, then the light is going to bend in this path instead. So it's going to bend away from the normal. If it were to be from a less dense medium to a denser medium, light would have bent towards the normal. So in this case now, this place is the angle of refraction, and this place is the angle of incidence. Now let us approach the problem. The problem talks about critical angle. Actually, you cannot have critical angle if you're not traveling from a dense medium to a less dense medium. So the concept of critical angle does not make sense if your traveling is not from denser medium to a less dense medium. And critical angle is actually the angle that you get to before you attain total internal reflection. So in this case now, whenever you say critical angle is a special type of angle of incidence when the angle of refraction in the less dense medium is equal to 90 degrees. So critical angle this is how you see critical angle. So this is, if you want to find the refractive index from a medium A to medium B, you can either use sine of the angle of incidence in medium A divided by sine of the angle of refraction in medium B, or you use the speed of light in medium A divided by the speed of light in medium B. Any of these two equations will hold. But in this situation, I'm just going to be coupling these guys together now, since I wasn't given a particular refractive index. So from this place, I told you already that the critical angle will represent the angle of incidence here. So that implies that we'll have sine. The critical angle is 45 degrees, so we have sine 45 degrees divided by sine. I told you already, when we have critical angle, the corresponding angle of refraction is going to be 90 degrees. It's going to be, by the way, you can check some of my previous videos. I've explained the concept of total internal reflection and how you actually get your critical angle. So in this case, we're looking for the speed in medium A, the speed of light in medium A. We already have that in medium B. So this is 3 times 10 to the power of 8. And if you do this very well, this would imply that sine 90 is 1. So that implies that VA is going to be sine 45 multiplied by 3 times 10 raised to the power 8, which is 1 over root 2. Sine 45 is 1 over root 2. 1 over root 2 multiplied by 3 times 10 raised to the power 8. 3 times 10 raised to the power 8. Of course, sine 90 is 1, so you don't have to bother about that. And if you press this on your calculator, that would be 3 divided by square root of 2. That's 2.12. So that's 2.12 times 10 raised to the power 8 meters per second. So the correct answer to that question is going to be option B, 2.12 times 10 raised to the power 8 meters per second. And that's it for question number 2. Don't forget to like, follow, and comment as well, and subscribe to this channel if you want to see solution to question number 3, that is on current electricity, question number 4, that is on field and electrostatic, and question number 5 is on atomic and modern physics. I'll see you in the next one.